Welcome back everyone. As you can see, I have made the figure of the forward bias in a little simpler way, as you have already learned the forward bias in this one. So here what we have learned is the positive charge and negative charge. Positive is connected with the positive terminal of the battery and the negative is connected to the negative terminal of the battery. So let's see what I want to teach you here. This region is shrinking here. So why it is shrinking here? Can you guess that? Because the supply of the positive or the holes increases here. So the supply of the holes increases, it start covering more area with the positive side or the hole side. Now the supply of the electron increases here, that's why it's negative, right? So the negative charge increases here, so the layer actually shrinks. And what the layer is known as? The layer is known as depletion region. So this layer is known as depletion region. So it depletes basically, that's why the name is depletion region. I think you get the point. Okay, now what in the next one we have? Next one, when we see, we can compare it here. In the reverse bias we have hole, electron, everything is very much similar, but the charges are opposite. The terminal of the battery is opposite. Here it's positive, here it's negative. It means what it means, we are going to see that here. So this is negative, and as we know, this is hole and hole is considered as positive, and this is the electron which is considered as negative. So the negative is attracted toward the positive and the positive is attracted towards negative. So in both the cases you can consider, for the simplicity, that it is pumping out the electrons and the holes. So when it is pumping out, the layer expands. The depletion region, the DR region, depletion region, I made a short form of it, you will not find that in book, that's my copyright, and never tell that to anyone. Okay, so this is the depletion region here. In this case it shrinks, and in another case it expands, and that is the fundamental difference between the reverse bias and the forward bias. So to understand its science, we have to go back on our. Welcome back everyone. As you can see, I have opened the slide of the forward bias. So why is the forward bias here? Because the question mark is still here. So we need to find the answer, right? So let's find the answer and get a little bit deeper into its science part. So what is the science part here? As you can see in the depletion region that you can name now, depletion region, it shrinks and expands that we have learned in the last two videos. So what is here? Here is a negative charge and here is a positive charge. To maintain the equilibrium in this, that is the interesting one, right? To maintain the equilibrium, like the positive charge is dominating in this place, so the negative charge attracts here, right? The negative with the positive. Fair enough. Like here is negative, so the positive is here. So this maintains the equilibrium. That's why it is known as the depletion region. It is maintaining both the areas and allowing it to transfer from one point to another, and that is actually making the things happen and making my figure more messy. So I'm going to remove this all the lines. Okay, now the next one, as we have seen here, it expands in the reverse bias, and the philosophy here remains the same. The holes are dominating, so the electrons are more, the holes are less here, the electrons are more, the holes come here. So it is equilibrium. So it is the equilibrium point that we do have. Now I have one more question for you which will going to excite you. So what I'm going to ask you here, this is the $1,000,000 question, buddy. So what is my $1,000,000 question? You are ready, right? You are ready. I think you are ready. So now what is the question? The question is something like this. Think. Imagine, my dear. So imagine the situation, that why it is happening. I am calling it hole, right? It's hole and this electron. So electron is something physical thing. It is having mass, charge, and all that thing. You can call it as positive, but it cannot travel, right? And I'm telling you continuously that it is pumping out, right? In this figure, I told you the pumping out part. So what is the pumping out? What does it actually means? How can the positive charge pump out when there is physically actually nothing? Just the positive charge. That is also because of the absence of electrons. So the absence of electron is making the positive charge. This is the bonding fact. You must think upon my question. If you feel like you can rehear my words again by pausing and repeating the things to understand the question. So I keep you with this question for a little more. In the next one, I'm going to answer this. So stick with me. Take care. God bless.